So, I have to prove I can do calculus. Fraser is always assuming I'm afraid of calculus, but I was an A student. I don't have any. I'm okay with calculus. Fraser's always assuming, I don't know, he's assuming I'm a fuck up. Fraser is. Didn't say Diana. Okay, so the first thing you have to learn about math is how to frame your problem. And the problem presented is find the minimum distance. Okay, so first of all, what we want to demonstrate is we can find the zero of a derivative in order to maximize. Since that is our goal, we're not going to do x, y, x, y. What we are going to do is x1, x2, and they're both at the same y. Or maybe we don't. Yeah, what the fuck it. Good enough. Okay, so x1, x2, and I don't know, x. So if you can do a problem in 2 dimensions, you usually can do it in 3. So that's the first lesson of math. So what do we want to do? We want to say when you there's a lot of situations where you have a cost or a score. As a matter of fact, let me digress. Oh well, never mind. Okay. So this is a good place for a cost. The cost is equal to oh, I'm tricky. Let's just fuck it. x1 minus x. Fuck yourself. Okay, so the cost is equal to x1 minus x plus, if you can do it in 2 dimensions, you can do it in 3 dimensions. Okay, x1 minus x plus x times x2. Okay, and now uh-oh, I think I got too clever. That's not gonna work, is it? I thought it was so x1 minus, why don't we do this like this? X minus 1 plus, I hope it doesn't cancel. Is it going to cancel? Yeah, no, yeah. Okay, let's just say 2x. What am I doing? Okay. That looks like a problem, doesn't it? Okay, so let's pretend it was not degenerate. Then we would have okay, just to make this interesting, let's say our cost was x1 plus x2 squared. Take the derivative, 0. Set it equal to 0. Let's pretend it was not 0 plus 0. Let's say it was 1. And you say 1, 2, 8, 0. Then you say x equals half. And now you have the critical point, the maximum, minimum, and that's the end. Okay, fine. So we have to do distance formula. Is this going to work? Why didn't... Well, that's true. The way I wrote it, it would be just the distance. Okay, so we got, let's say y. Okay, so we have x minus x1 squared plus y squared square root plus square root plus y. Okay, let's just do it. Squared minus 2x x1 2x x1 plus x1 squared plus y squared. So my computer crashed. It's either Linux or it's a bug in the Xeon. I guess it's Linux. I have a monster Xeon. It could be the... been doing it. So God does this frequently. He will make you start over. You can say, he must want me to abandon. No, usually what you do is you just start over and say, fuck you, God, I'm going to finish. And that's the... You have to start over, say, fuck you, God, I'm going to finish. he did that a lot of times, I would lose my work. I would have to start over. I could have said, it's a sign from God. Could be a sign from the CIA crashing my computer. Cost equals square root. Well, let's just write the answer. 2x squared plus 2x1 x plus 2x2x. Okay, is this going to be minus? Let's see. These are both negative. Minus 2. And it's going to be plus x1 squared plus x2 squared. Oh, we got a y, don't we? Okay. So, oh crap. You know what? We have to do square root. X squared. Square root. Sometimes have to not be lazy. Say fuck you. God will crush you. You just gotta say fuck you. Okay. So square root x squared x1 x. Why am I doing? Oh, we got a y in here, don't we? I was wondering why I was in that situation. Okay. So hey, let's make it a different. Let's make it a mass spring. And do the Jacobian and linearize and make it a predator prey problem. Never mind. Anyway. Okay, so so y is a constant, x1 is a constant, x2 is a constant, and we just want to find the zero. Square root b squared. Let's see, b squared 2x1 quantity squared b squared plus minus square root. Why do we have a square root? We have to take the derivative. Cost prime equals. That was the whole point of this exercise. And we got 2x minus 2x1. And those are history. Yay. Oh, we have to do the chain rule. Okay. Is that what you call it? I cheated. Okay, so derivative, the composition, I think you just multiply. We take if you have f of g of x equals f prime g of x are you shitting me? And the opposite of this gives you integration by parts. Is this what we're doing? I think it is what we're doing. Okay. Fine. So if this 1 divided by square root. This puppy. Okay, the derivative we take to the 1/2. So we say 0.5. Multiplied by, that's the derivative. Oh, crap. That's f prime. I guess so. I got a bad feeling about this. Wait a minute. I guess so. What's the other one? And okay. So I guess we could physically write the motherfuckers. I don't want to do that. But if I get confused, I just might have to do it. No. F of x. So, wow, that's pretty crazy. You think that's what it is? Okay. Well, we know it's going to be the midpoint. So, how would we, so we would set the sequence. I don't even know if I did this. I mean, so 0. And so we get this side equal to that side. I hope we don't have a problem. I might have a sign issue. Or should I know from symmetry? Oh well. Anyway, so is this just degenerate? Find the value of x such that this is true. Oh, this is one of those problems. There, 0 is a solution probably. No, we don't want 0. Square root x blows up over square. What would happen if we had 0? What is that? What does that mean physically? Why would 0 blow up? The cost would blow up. That doesn't sound right. If we put x0, it shouldn't blow up. Why would it blow up? The derivative of the cost. Okay, it's the slope of what we're looking at is the plot of what we're looking at. We know what it is because it's what it has to be. It's this. It's quadratic. It's a minimum. It's quadratic and it's a minimum. Or is it quadratic? Of course it's quadratic. What the hell else would it be? We got a square root on the bottom. That could be a problem. Well, it probably looks quadratic. It's symmetric. So, so the slope goes to infinity. So that's good. The slope blows up. What about, wait, that's at 0. What does that mean? We don't even have a 0 is not even a, we have a, something is broken. I didn't feel very good about this decomposition. F square root of x. I get a bad feeling about this. What if it cancels out? Why not? We can cancel that part out. So let's just cancel this half. And then we have this half. Oh no. Oh, there's a 0. So 0 is a solution. 0 is a 0. And 2x minus, so x minus x1 is equal to x. How about that? X minus x1 is equal to x minus x2. And the solution is what if we didn't have? We're really close. 2x. I bet what this is supposed to be is what we want is x equals x1 plus x2 divided by 2. I think that's what we want. So we will shamelessly work backward because fuck it. So click. Okay, so we got what we're supposed to have. How can we get those on the same side? That doesn't happen. So if x is 0, no, you don't. X equals 0. This is broken. What if failure was not an option? I got nothing better to do today. No, we can figure this out. It's just a matter of let's see if we got this right. X squared. So this is x minus x1. This is correct. I am certain this is correct. We can't do anything to that, can we? Can we bring anything out? No, we can't really do anything. We can't really. What if we tried to solve the quadratic formula? No, there's no point solving the quadratic formula because we definitely are taking the derivative, and that's gonna ruin whatever it was. So we are definitely taking the derivative. F g of x f prime g of x. Now there's, what if you have, is this the composition? No, this is multiplication. I always get those fucked up. Okay, so there's f1 times f2 equals f1 prime times f2 plus f1 f2 prime. Okay, for the composition, I think it's even easier. Isn't this even easier? I could swear it's easy. Shut up, Mom. I'm trying to concentrate. Mom's talking to the dog. I can't concentrate. She's calling it a brat. I think it's easy, isn't it? What if let's do a test case. The chain rule. I think it's even easier than multiplication. What if we had, for example, oh, I know this. What if we had sine of x squared? That's equal. Oh, you just multiply the derivative outside. Is that all you do? That's what you do. That. All right. Is that all it is? I guess. So, and, well, that's nice. Okay, I knew it was easier. I remember it was easier. That much I remember. Okay, square root. So cost is, take the derivative. Okay, well that's a lot. I like that. I like that a lot. Okay. If failure is not an option, we will get this done. Okay, let's see. that's only half of it. Half of it. Let's see. 2x. I have a bad feeling, but you never know. Okay. So, it's equal to 0. Oh, let's just knock off the square root and get rid of it. So we got 0.5, 2. This doesn't look good. I don't think this is right. I don't think it's going to work. Oh, it's a minus. That's good. No, it's a minus. I think that's good. I think that's good. Okay, we got rid of the square root from both sides. And 2x minus squared. Okay, and we can get rid of the 0.5. And what are we left with here? We are left with, oh, this is good. That's good. Okay, let's get rid of them. Okay. And, hey, what happened to y? Are you sure we got rid of y? I got a bad feeling. Oh, well. Of course we got rid of y. Okay, so, why did you move it over there? Yay, I think we got it. Yay! Yay! I should review I want to review my Laplace transforms. There's a bunch of if you think this is forgotten, I really forgot my Laplace transforms. Okay. I did it there. I did it. Now what if it was y1, y2? It's a constant. y1, y2. Oh, this is the real problem. I was thinking it was. This is the problem. Okay. Something's broken. Oh, you know what? You don't do that. Wait. When you take a Taylor series, for example, I think, do you put the whole thing in there? What happened to Y? Y? How did we get rid of Y? I think we screwed up. What are you doing? Something is rotten in the state of Denmark. Okay. Are you sure they cosine 2x? Oh, x squared. Oh, look at that. Is it x squared inside? Yeah. That's the problem. Okay. What? Are you sure? Okay. That's the problem. Okay. So, we take F. I don't know why this hurts my head. Take the derivative. There's the derivative. Oh. I can't concentrate. Okay, this, the other way around. This times, okay. Okay, that's the right answer, but I'm going too fast for my own head. I know that's correct, but I have to slow down. Okay. Okay, so what's gonna happen? Are you sure you did that correctly? Take the Of course that's what he did. He just take 2x plus. Okay. So we have here. Okay, so let's start just busting some stuff out. Okay, we can get rid of the 0.5. Right? Right. Are we sure? I do believe so. Yep. 0.5 is gone. What else can we do? Okay. We can write it. Okay. So okay, now we have now we can put them on opposite sides and multiply. How about that? Let's do that. Okay, so we got this on one side and that on the other side. Oh, this is gonna be very nice. Well, it's gonna be awful. Okay. So now we put this over here and that over here. Okay, and now we okay, so the quadratic formula will provide zeros but those are not zeros. Okay, if we made this 0, we would have one side 0. But that is not a solution. That's good, because I don't want to do the quadratic formula. Okay. So you know what we do? I'll tell you what we do. What if we square? Can you do that? Square both sides. It's been a while. Can we square both sides? I think we can. Okay. What are the implications if we square both sides? Okay, so they're equal quantities, so if we multiply, we can, yes, we can square both sides. Okay, so 4x squared minus 4 minus 8x. Oh, let's get rid of the, let's divide by 2. Hold on a second. Okay, divide by 2. Divide by 2. Divide by 2. Divide by 2. Okay. So now we got x squared minus 2xx1 plus, better not do that, plus x1 squared. Okay, and this has become squared. Okay, so this is still, I have a bad feeling if we got rid of the negative. Did we screw this up? You can square both sides, can you not? Multiply by itself. Of course. Okay. Squared. How come we got rid of the negative? Okay. And now well, we see where this is going. Okay. So what are we going to get? We're going to get a fourth order polynomial, and we take the roots of a fourth order. Is it going to be squared? What if we could complete the square? First of all, we know the solution. The solution is, why don't we do the solution? The solution's not that bad, so I'm kind of skeptical that I don't think a fourth order polynomial is the final answer. I don't think a fourth order, oh, I squared it, didn't I? I don't think a fourth order polynomial is to find. Oh, what are we looking for? We're looking for x. Oh, when you square, is there a plus or minus that you cause? Plus or minus, you entered. I think you might. Okay, so are we going to be able to simplify? If we can't, if we're stuck with the fourth order, that's the end. But we shouldn't be stuck with the fourth order. Let's ask God. I got nothing better to do today. Oh, just do it. Don't be lazy. X squared. X squared. Oh, what the fuck? X fourth. Multiplying by x squared minus 2x third. What's 2x 2x? I think that's probably x third x2 plus x squared. Why don't you do this? Oh shit. Damn it. I hit dollar sign. 2x third x2. Do this like a white man. X2 goes here. Okay, and we're multiplying by x squared. How hard can it be? Okay, so x2 squared x squared plus y2 squared x squared. Just do it. Minus 2 x1 x cubed minus 2 cubed plus 4 x2 x1 x squared by symmetry. These are perfectly symmetric. Equal. What is symmetric? I think X1 is What is this? Shit. I think it's a plus. It's a plus. Okay. So, oh, that's nice. So we get rid of the x to the fourth. Let's just take this quickly. Paper is not expensive. Okay. What else can we get rid of? Nothing. So third order. Does third order make sense? I think there's a closed form. There is a closed form solution. What if, well anyway, okay. So this, we move to the other side, and it becomes a plus. As a matter of fact, this becomes a minus x squared minus x squared. Oh shit. What happened to our plus we had here? Should we do this separately? But let's do it like that. Let's go slowly. Get a minus. So there's an x squared plus x squared. Okay. 7x cubed. There's an x squared. X. These are all constants. Okay. Now, this is not a hard problem. It should be basically a line, some silly line. Oh, we can simplify a little bit more. Just keep at it. X1 and 2x1, 2x1 and 2x1 and 2x2 and 2x2. Holy shit, it's gone. How did that happen? Okay, I guess when well, yay, we can do it. Closed form. Okay. X1, X2, 4, and minus 4. This is gone. Okay, let's see. Yay. Okay. Is this the square of something? And we have x1, x2, y1, y2. Is this this? Is this the square? Okay, we have a. Okay, concentrate. Let's see. I do believe it's x1 times x2. Not a square. I didn't mean a square. X2. Uh-oh, it's x1 squared. x1 That's not a good sign. We have x1 in there. Okay, well. x1 squared x. Uh-oh, there's an x squared. What's this doing here? What's this doing here? You're not supposed to be there. Oh, it's a squared. Okay. Oh, what? What are you doing there? You're not supposed to be there. x1. Okay, why don't we just minus b plus or minus b plus or minus square root b squared minus 4ac all over 2a. Okay, now we're done. We are done. Okay, are you happy? Would we get two? Why would we get two answers? Is that's not very reasonable. I squared, maybe I caused it? I don't think so. What would a negative answer be? Well, if it's negative distance, it's no good. That's probably what it is, or something, I guess. Look, I don't know. Okay, you came this far. What's God say? Not bad. Oh shit, you want me to do it? Boy! Boy. I bet you can't do it, Mr. God. Fortitude. Oh, some other day. We can do it. Why don't we? I couldn't do that in a minute. No, it's not.